Hello Jams, welcome to first episode of A series. In this video, we are going to discuss about previous year BITSAT questions from the chapter of units and dimensions. Okay, so before starting straight with this video, make sure that you are well versed with the ethics of units and dimensions. If you are not, go check out the description box, and if you are, let's begin. Okay, so let us begin the discussion with some simple straightforward questions, and as the video proceeds we are going to go on increasing the level. So first question on the board, unit of specific resistance. Now what is specific resistance? Specific resistance is nothing but resistivity, right? Another word for resistivity. So some of you all might directly know its unit. What is the unit of resistivity? Ohm meter, right? So ohm meter, option C is the correct choice. Those who don't know the unit directly can use R equals rho L by A. Okay, so this rho is our specific resistance or resistivity. So make that a subject since we want its unit. So RA by L, and now you can substitute the units. R is resistance measured in ohms, A is area, meter square, L is length, meter. So this and this will get cancelled. Ohm meter, right? Option C are the correct choice. Okay. Coming to question 2, dimensions of strain are same as. Okay. So we have to find one quantity among the option which has the same dimension as that of strain. Now what is the formula of strain? How is strain defined? Strain is defined as change in dimension to original dimension. Okay. In a general way, change in dimension to original dimension. So can you feel that strain is dimensionless, right? Change in dimension to original dimension, so that will be dimensionless. Okay, so strain is dimensionless, so we have to pick one dimensionless quantity from here. So which is that? Angle. Okay, so angle, so that is the correct choice, and others have dimensions. Okay, none of the others A, B, D are they are not dimensionless. Each of them have some dimensions. Okay, let's not worry about that. We got our answer. Answer is C, angle. Okay, which is dimensionless. Now question 3, group with different dimensions. Okay, so they have made groups over here, nice groups. You have to find a group with different dimensions. Okay, so the first group, EMF, voltage, potential difference. Now what is this? Nil, Nitin, Mukesh, right? So three different words for the same thing. Okay, EMF, voltage, potential difference, all of them mean the same thing. Okay, so all of them have the same dimensions, you'll know it. Okay, so voltage, EMF, potential difference, all of those are the same thing. Okay, now coming to the next thing, next group, pressure, stress, Young's modulus. Now I don't have any straightforward way of doing this, so that's why I am negating the options. Okay, so pressure, stress, and Young's modulus. You can see that pressure is force by area, stress is also force by area, right? And even Young's modulus, if you see, it's stress by strain. Okay, Young's modulus is stress by strain. Strain is dimensionless, so Young's modulus has the same dimensions of as that of stress. Stress has the same dimensions as that of pressure, right? Force by area. So this is not the correct choice. Coming to the third option, heat, energy, work done. Now if you see it thermodynamically, heat, energy, and work, all of them are forms of energy, right? Loosely we can say that all of them are forms of energy, so even they have the same dimensions. You might know the first law of thermodynamics, right? So by principle of homogeneity, you can say that Q, U, and W have the same dimensions. So again, this is out. Okay, so only option left is D, which will be the correct one. You can surely verify it. That will be difficult to verify. Okay, so negation was a good way of doing this question. Coming to the last question, last easy question, it says dimensionless quantity with unit. Does this remind you of the supplementary physical quantities? Okay, so what were they? Angle and solid angle, right? Only they had they were dimensionless, but they had units. So we have to either look for angle or solid angle. So here, angular displacement. Okay, so this is the correct choice. This has a unit of radians, right? Angular displacement is measured. Now this basically means angle. Okay, they have just added a word angular displacement over there. It basically means angle. So it's measured in radians, right? It has a unit radians, but it is dimensionless. and all of these quantities, strain is dimensionless as well as unitless. Reynolds number is also dimensionless, unitless. Poisson's ratio or Poisson's ratio, whatever you call it, it's dimensionless, unitless. Only this one has is dimensionless but has a unit radians. Okay, so time to level up the discussion. You can note this down. Okay. Okay, so here is question 5. You can surely try it out by yourself. Okay, I'll do it in 3, 2, 1. Pause and try if you want to. Okay, so here T, it is also a straightforward question. T is defined, T is time period, M is mass, L is length, Y is Young's modulus, Q is something which we don't know. We have to find the dimensions of Q. Okay, so that is our job. So let's just do it. So first thing to do is make Q a subject, right? We want to find its dimension, so make it a subject. So we'll square on both the sides and we'll shift that Q. Okay, so I'm skipping those steps because no marks for steps, right? So I've shifted that Q. I've also squared the equation. So 4 pi square, this under root sign will go m l cube by y, and that T will come to the other side, but the equation was squared, right? I had squared on both the side. Now again, no point in writing that 4 pi square, right? Because that is a dimensionless constant. It does not have any dimensions, and once we take dimensions on both the side, it dies out. Okay, so M has the same dimensional formula, L cube, right? They are mass and length. T is time. So again the same thing. Y is Young's modulus. So we have to look out for the dimensions of that Young's modulus. So Young's modulus is nothing but stress by strain, right? Young's modulus is the ratio of stress by strain basically. Okay, so the strain is dimensionless. So basically Young's modulus has the same dimensions as that of stress, something which we discussed previously also. Okay, so Young's modulus has the same dimensions as stress. Stress is nothing but force by area. So just find the dimensions of this. Okay, force by area. Okay, so let's do it over here. Force by area. So force is mass into acceleration. Mass into acceleration, L t raised to minus 2, right? Mass into meter per second square, m t raised to minus 2, right? Area is length square meter square, right? Now simplify that, that will go on top as minus 2, and here we will get minus 1. Okay, so m L minus 1 t raised to minus 2. So let's substitute that over here and look and see what do we get. M L minus 1 t raised to minus 2. Okay, so this m will get cancelled with that, and t square and t raised to minus 2, t to the power 2 and t to the power minus 2, that will also get cancelled. Okay, and here you will get L to the power 4, right? This will go on top as plus 1, so 3 L to the power 3 plus 1. Okay, and you'll get L to the power 4. Okay, so the correct choice is D. Okay, so you can note that down. Also, the notes of this are available on the website, so you can download it from there too. Okay, now let's go to the next question. Let's increase the level a bit now. This was also easy peasy. Okay, so here is question 6 from the papers of BITSAT 2017. You can surely give it a try. It's a good one. I'll do it in 3, 2, 1. Okay, pause and try if you want to. Now again, a relation between x, y, z is given. X is capacitance, z is magnetic field. You are again asked to find the dimensions of the unknown quantity, the dimensional formula of the unknown quantity, which is y in this case. Okay. So basically this question has a catch point, right? Because how to find the dimensional formula of magnetic field of capacitance, it's tough, right? If you go by this formula, suppose magnetic field, if you use this formula, mu0 upon 4 pi I dl sine theta upon r square, okay, you'll get lost, because this mu naught itself has some dimensions, okay? It is a dimensional constant, okay? It has some dimensions, okay, which are unknown. So you cannot find the dimensions of B using this formula. Now the best way to find the dimensions of B magnetic field is using the Lorentz formula. F is equal to QVB, charge velocity into magnetic field. Of course sin theta, but dimensionally you know it flies off, okay? Now what about capacitance? Again, if you try to find it by A, epsilon naught by D, you'll get stuck, okay? Because again, this epsilon naught has some dimensional constant, and you cannot find its dimensions through that formula, okay? So the best way to find the dimensions of capacitance is using this formula, half q square by c. This is energy stored in a capacitor, right? So that is the best way to find the dimensional formula for capacitance, and this is the best way to find the dimensional formula for magnetic field, okay? So let's do that job. Okay, we'll find the dimension, substitute over here, get y, okay? That is our job. So let's find the dimensions of B, which says f by qv. So f has a dimension m l t raised to minus 2, mass into acceleration. Q has dimensions a t, right? Q is electric current into time, right? Charge is a current into time, so basically by formula, okay? At, so, and velocity, right? So velocity is meters per second, lt raised to minus 1. Now this L and L will get cancelled. This T and T raised to minus 1 will also get cancelled, and you will be left with m a to the power minus 1 t to the power minus 2. Okay, so that is the dimensional formula for B. Now let's go to C. Let's find the dimensional formula for C. Here only we'll do that. So C, now this half is constant, so remove that off. Dimensions of q square by dimensions of u, right? So q square is a square t square, right, from here, and u is basically energy, right? Energy has dimensions, mass into velocity square, mv square, half mv square you can use. So energy, the dimensions of energy you'll get over there. So over here, so let's find the dimensions of C over here. So A, so you'll get m minus 1 first of all, a square, again you'll have L to the power minus 2, okay? I'm just shifting that up, and again if you move that up, so T 2 plus 2, okay, that will be 4, right? So this goes on top, it becomes 2, so 2 plus 2, 4, okay? So dimensions of C over here and dimensions of B over here, okay? Magnetic field and capacitance. So let's substitute that in this, and let's find the dimensions of Y. Okay, so this was a good one. So we have to find the dimensions of Y. So x upon z square. Okay, 3 is of no significance. So Y. So x has dimensions, x is capacitance, right? So it has dimensions m minus 1 a to the power 2 l to the power minus 2 t to the power 4. Okay, and coming to B, z is magnetic field, okay? We have to square it, okay? So m a to the power minus 1 t to the power minus 2, and that squared, okay? So we have to simplify this now and we'll get our answer. You can see that it will be m to the power minus 3, okay? So these 3 options are left, option C is gone. L to the power L, look out for the power of L. Here there is no L, so L to the power minus 2, so only these 2 options are left. D is again wrong. Now T, you can look out for the power of T or A, any one will do. So this will become a to the power 2, and this will also become a to the power minus 2, okay? And that goes on top, so a to the power 4. So we should get a to the power 4 option B is the correct choice. Okay, don't solve it, just use logic, right? We are concerned about the answer, okay, not about solving it. So you can note that down. Let's move to the next question now. So here is question 7. You can surely give it a try. It's from BITSAT 2006. Okay, so I'll do it in 3, 2, 1. Okay, so Henry, who is this Henry? Henry is the SI unit of inductance. As you'll know it, it's not the neighbor's kid, it's the SI unit of inductance. Okay, so Henry cannot be expressed as, or cannot be written as. So there are 4 options. So one among them does not represent Henry. Okay, so suppose this is Henry, this is Henry, this is Henry, this is not Henry, this is something else, suppose. So this will be our answer. That is what the question means to say. Okay, so let's do it. Now here I can see Weber. Now there is no straightforward way, so I am going to negate the options. Okay, so A is Weber by ampere. So I see Weber over there, so I'll use the formula phi equals Li. Okay, because phi is has a unit of Weber, right? The flux has a unit of Weber and I has a unit of ampere. Okay, and this L is nothing but inductance, right? So this inductance has a unit of Henry. So Henry, this has unit of Weber and this has a unit of ampere. So Henry can be expressed as Weber by ampere. Okay, so Henry can be expressed in this way. The question is about cannot. Okay, so this is not the answer that we want. Now again, let's go one step further. It means volt into seconds. Okay, so here we can use Faraday's law. Okay, just exclusively using the formulas. So E is equal to d phi by dt. Okay, let's keep the sign away, let's forget the sign. So you can see that d phi is E dt. Okay, or dimensionally you can also refer as phi is E into T, right? E is EMF, right? EMF is measured in volts, right? Voltage, volts. So you can replace this phi by ET by I. So ET, volt, second, this is volt, this is second, this is ampere. So again on the other side you have L, right? I just modified this formula. Okay, so you get volt second by ampere. So Henry can be expressed in this way also. This is also the wrong choice. Now this might seem absurd, right? How did Joule come over here? This might seem absurd, but Henry can be expressed in that way also. I'll show you how. Okay, so this is also the not the correct one. So the last option, ohm meter, which was the unit of resistivity, is the correct answer. Okay, let's prove this wrong first. So Joule, how to get Joule from here? If you remember, voltage is nothing but work, the amount of work required to bring a unit charge from infinity to that point, right? So voltage is defined that way. So a work done per unit charge. Okay, so here you can replace that E is voltage, basically EMF, voltage or whatever. Okay, so dimensionally everything works. So you can replace it by WQ T by I, and on the other side you still have L. Okay, now this Q can be written as IT, right? Current into time, right? I'm just using the formulas, right? Nothing more I'm doing. So this T and T can get cancelled. You can see this is work. Work is measured in joules. This is ampere, this is ampere. So it means ampere square. Okay, so ampere square, joule by ampere square. Again you have Henry over there. So this is also, Henry can be also expressed in this way. So this is not the correct one, and the only one that we are left with is ohm meter. Okay, so that is the correct answer. Okay, let's move to next question now. Okay, here is question 8. You can surely give it a try. Now you can see that this question is from the error and measurement section of this chapter. Now I'll just tell you what the question says. This is the length, this is the breadth, this is the height. You are supposed to find the volume. Of course, the question was framed in a beautiful way. I've just stated it in a haphazard way. Okay, so volume, how will you find that? Now somebody might be complaining, how is this a BITSAT question? Okay, you'll come to know how. So length is 1.2, breadth is 1.5, height is 1.8. Okay, so once you calculate this, if you go to calculate this, the answer that you will get is 3.240 centimeter cube. Okay, and now don't be in a hurry to mark this. Okay, this is in fact not the correct answer. Okay, because of significant figures. Now those who don't know significant figures might be scratching your head, how is this different from this, right? You will be thinking, how is 3.240 different from 3.24? They mean the same thing, right? No, they don't. Okay, so if you want to know the difference, go check out the video on significant figures. Self promotion. Okay, so the basic difference in one word, if I had to say, accuracy. Okay, this is like more accurate than this one. Okay, it has more significant figures. So yeah, so this is not the correct one, even this is not the correct one. Those who know significant figures will know that C is the correct answer, because if you see here, length has two significant figures, right? Two sig figs. This also has two significant figures. Breadth, height also has two significant figures. So the answer will not have more than two significant figures. Rather, it will have the least among them. Since all of them have two, the answer should also have two. Now, now you have to drop this, right? Drop 0, drop 4. So the answer that you are left with is 3.2. Okay, so that is the answer and not this. So that's how it's a BITSAT question. Now over to the next question. Okay, here is question 9. Give it a try. It's from the most important part of the chapter. It's from the applications of dimensional analysis, right? So I'll do it now. Okay. So here we have, they have given us an equation. F is force, A is area, V is velocity, D is density. So we are supposed to find the values of A, B, C, right? Quite an easy job. So how to do it? Apply dimensions on both the sides. So force has dimensions mlt raised to minus 2, mass into acceleration, area is L square, meter square, and the whole is raised to A. Okay, and then we have velocity, meters per second raised to B. Then density, mass by volume. Volume is L to the power 3, right? Volume is L to the power 3, mass by volume. So bring it on top, minus 3. Okay, so you just have to compare this now. mlt raised to minus 2. So here you will get L. So first m to the power c. Okay, I'm just combining them now. M to the power c, L to the power 2a plus b, right? B from here, and minus 3c from here. Okay, and t to the power minus b. Okay, so basically minus b is equal to, just compare now, compare t, powers of t on both the sides, powers of L on both the sides. So leave that L away. So b is 2, m, let's go for m. So m powers of m, c is 1, c is 1, b is 2, b is 2, b is 2, yeah, b is 2, c is 1. This is the one. Okay, you can also find the value of a, it will be 1, right? So let's just verify that. B is 2, 2a plus b minus 3c equal to, equate the powers 1. Okay, 2a plus b, b is 2, 3c, 3c minus 3, right? 1 you will get. So 2a equals, so this will be minus 1 equals 1. So 2a is 2, so a is 1, right? So a is 1, b is 2, and c is 1 again. Okay, so that was quite an easy question from the most important part of the chapter, most important part of our chapter. Okay, you can note that down. Let's move to the next question. Now just a question that I missed out, it's about significant figures. Okay, I'll do it over here only. So the question that was asked was, what are the number of significant figures in this number? Okay, what are the number of significant figures in this number? And if I'm not wrong, it was in 2010. Okay, so you have to just count the number of significant figures. I hope you know how to do that. So this 0 is not significant, right? 0 before the decimal, not significant. This 3 is non-zero, significant. Even this 0 is squeezed between these two non-zeros, so that is also significant. These two zeros comes after decimal, they are also significant. Okay, so this has 5 significant figures. Okay, so that was the answer. Okay, so this was also one more question, one more simple question that I missed out. Okay, let's move to the next question now. This was question 10. Okay, this was question 10 for website people. Okay, question 11 over here. This is not a BITSAT question. This is something which I am adding from my side. Okay, so this is based actually on the 9th question, wherein we used application of dimensional analysis, right? This is also based on the same idea. You just have to catch it. Okay, so energy, angular momentum and velocity are chosen as fundamental. Okay, are chosen as fundamental. Then find the dimensional formula of pressure. Okay, so that is the question. Might seem very different, right? But it's same like the 9th question. Okay, so all you have to do is dimensions of pressure equals dimensions of energy raised to A, dimensions of angular momentum raised to B, and velocity raised to C, right? You just have to find a relation between pressure and this 3, right? Pressure equals something of this 3, right? Some powers of this 3. Okay, so the same idea of finding A, B, C, right? So it's the same question, same breed question. So let's do it. So pressure is force by area. So force is mlt raised to minus 2, mass into acceleration, and per unit area. So by L square. So by L square means 1 minus 2, right? By L square. So this 1 and minus 2. Okay, so I'm directly doing that. So you'll get minus 1, right? So force per unit area. Energy is ml2 mass into velocity. You can do mass into velocity square. Your angular momentum mvr, you can use mv and r. So ml2 t raised to minus 2 whole raised to b. Don't forget that. C is velocity, right? Velocity is lt raised to minus 1 and raised to c. Okay, so now bring this together. So m is raised to a plus m raised to b. So m raised to a plus b, L raised to 2a from here, and plus 2b. Okay, 2a plus 2b, and here you have c, right? Okay, and from here you'll get t raised to minus 2a minus b minus c. Okay, now this might seem complicated, but let's do it. So a plus b, we just have to compare. So a plus b, powers of m should be equal to power over here. So a plus b is 1. Here we'll get 2a plus 2b plus c equals power of L, yeah, minus 1. So here you can see that a plus b is 1. So I'll do a smart work over here. So take that 2 common. So I'll get a plus b over there plus c equals minus 1. So a plus b is nothing but 1, right? So 2 into 1, 2 plus c is minus 1, and c is minus 3. Okay, so c is minus 3. C is minus 3. So c is minus 3. So c is, yeah, minus 3. So 1 by c to the power 3. So which equation has that? Only this one has. Oh wow. So this is the correct answer. Okay, again this is not a BITSAT question, but it was a same breed of that 9th question, right? So it was something different, so I brought it to class. Okay, so you can note that down. Okay, question 12 over here. This is a very good question, again not from BITSAT, just to give you a practice. Now x is defined in this way. You are supposed to find the dimensional formula of x and then see which has the same formula as it. Okay, find the dimensional formula of x is same as which of this. Okay, any one option will have the same dimensional formula as x. Okay, you are supposed to find that. You can surely try that out. It's a very good one. Okay, that's why I brought it to class. Okay, so I'll do it now. So one straightforward way of doing it is just doing it, right? Just do it. So first you'll find epsilon naught. How will you do that? Use Coulomb's law, right? 1 upon 4 pi f q1 q2 by r square. Okay, just flipped f in epsilon naught. So you can find the dimensions of epsilon naught from here. Again, voltage, if you want to find, you can use work by charge, right? You can find the dimensions from there. A lot of hard work, and then get those dimensions, get this dimension, bring that together in x, then find the dimensions of this, compare with that, right? So just a very big job, right? But I will give you a hack, right? I will give you a hack from which you can solve this question orally. Okay, so the hack is epsilon naught into L. Epsilon naught into length is capacitance. Okay, so how did I get this? First of all, C is A epsilon naught by D, right? The formula for C is A epsilon naught by D. So you can see that this is area and this is some length, right? Meter square meter. So you can basically see epsilon naught into meter, epsilon naught into length. So dimensionally, capacitance is same as epsilon naught into L. Now this is the hack. Okay, and if you are noting down whatever I'm saying today, mention this separately. Okay, this might help you someday. Okay, so that was the hack, and now you can do the question orally. Okay, so epsilon naught into L is C into V. C into V is capacitance into voltage is charge, right? Charge, and charge per unit time is current, right? Rate of flow of charge is current. So answer is current. How did I do this? Let's repeat that. So epsilon naught into L is C into V by delta T, right? CV is Q and Q by delta T. Rate of flow of charge, you can say that it is current. Just like IT is Q by T is I. Okay, so it was so easy to do this, right? And now I know it was not that approaching. Why will you go to capacitance when it is not mentioned in question, right? Why will you go to this? Okay, so also when I did it for the first time, I was like, when I found this problem, I was like, how will you do this? How will you find it is so much of hard work, right? So I went to the solution side and it was like epsilon naught into L, it's C. Okay, so then I got it and then I brought it to class. Okay, so that's my story with the problem. Okay, you can note that down. It's a very good one. Okay, so one more homework problem and then I'll give you some tips and then I'll leave. Okay. Okay, so this is your homework problem. You should try it out yourself. Okay, y is pressure, x is velocity gradient. Velocity gradient means velocity by length. Okay, so you have to find the dimensions of d2y by dx square, the second derivative of y with respect to x. Okay, so you have to comment this answer. The correct answer will as usual receive a heart from me. Okay, so just few tips before I leave. So the questions might have made this very clear to you that this chapter is purely a play of formulae, right? The more formulae you know, the better for you, right? So I wish to emphasize over here not just formulae but better versions of formulae, right? Just like knowing C equals A epsilon naught by D was not useful, right? We could not find the dimensions of dimensional formula of C using this, right? Using this equation, we could not find out the dimensional formula of C. So the useful one by better versions, I mean somewhat like formulas like this, right? We can find the dimensions of C. Also for magnetic field, this was not a good way of approaching it, right? The Biot-Savart's law. So what did we use? We used the Lorentz force, QVB. Also we learned one result, epsilon naught L into L equals C, so which helped us a lot during that second last problem, just the previous problem, right? Also like one elegant way of saying this convincing you about my point is a JE question. It had asked you for this, the dimensional formula of mu naught into epsilon naught. So one way is the hard work way. You find the dimensions of mu naught, you find the dimensions of epsilon naught through Coulomb's law, and then multiply and then find the dimensions, the hard work way. The smart work way was knowing this fact that mu naught into epsilon naught is 1 by c squared. C is nothing but velocity, right? It has the dimensions of velocity. So you could have simply used this formulae and found out its dimensions. Okay, so not just formulae, but the better versions, the best versions of the formulae. Like many of you all might be doing this, right? If I tell you to find the dimensions of gravitational constant, okay, you will be doing this, I know. So you'll use F is equal to G m1 m2 by r square. Okay, again, not so big approach, but still a way of hard work. You could have just used gm is equal to gr square. Ever thought of this? Right? So I wish to say, like, prefer smart work over hard work. Okay, don't get into the hard work. There will be a easy way out. Find the best versions of the formulae that can help you dimensionally. So this chapter is all about that. So just do it the way a Bitsian would. Okay, so with that being said, let's end today's class. I'll see you soon in the next class of A series. Also follow the word series which is going on my Instagram. Links in the description. I'll see you soon in the next class. Till then, keep enjoying physics.